Square root functions, chapters 1 and 3. Parabolas that open left or right fail the vertical line test and therefore do not express y as a function of x. For example, parabola y squared equal x is graphed below here. You can see it fails the vertical line test. But if we solve the equation for y, we can split the relation into two functions. So y equals square root of x, take the square root of both sides here. Y equal, and x usually has two square roots. Y equal positive square root of x would be the upper semi-parabola, and that's just that much here, eliminating the bottom part. And that passes the vertical line test. That's a parabola. That's a semi-parabola, and that's a function. And y equal negative square root of x, that would be the lower semi-parabola. So you can split the conics into two pieces, and each piece separately would be a function. And here's some other examples. Parabola I just went over, but also a circle. A full circle is not a function, but if you split it into pieces, each piece will be a function. So the upper semicircle is pictured here. Y equals square root of 1 minus x squared, and that would be a function. Functions are important because certain procedures in calculus can only be done on functions, so if you want to do something on calculus on the circle, one way of doing that would be to do it on the upper semicircle and the lower semicircle separately. Okay, here's some more examples. Hyperbola. Y squared minus x squared equals 1 is not a function. It fails the vertical line test. But if you look at each piece separately, for example, the upper semi-hyperbola, y equals square root of x squared plus 1 is a function. It passes the vertical line test. Here's a hyperbola opening left and right, also not a function. It fails the vertical line test. X squared minus y squared equals 1. But if you split it into two pieces, each piece separately would be a function. This is the upper semi-hyperbola, y equals square root of x squared minus 1, and that would be a function.